Hello, my dear students, and welcome back. I know, your exams are just around the corner, but please don't you worry. Today, we're going on a super fun adventure into the world of acids, bases, and salts, and I promise you we're going to make it so simple you'll remember every single bit of it.
All right, let's jump right in. I'm sure every one of you has heard this from your mummy, right? Beta, don't keep the achar in the steel dabba. But have you ever stopped to think why? What's the big secret? Well, guess what? By the end of this chapter, you're going to be the one explaining the science to her.
Okay, so in our little adventure today, we have some main characters. You can think of them as heroes. And we also have some secret agents, some spies. So come on, let's go and meet them.
So, first up, let's meet Team Acid. I like to call them the Karta Kings. Why? Well, because they taste sour, just like Nimbu or Tamarind. And their superpower, they can turn blue litmus paper red. Remember that. Now, for the other team, we have Team Base, the Karua crew. These guys are bitter, like Karela or Neem, and if you touch them, they feel all soapy. Their special power is the opposite. They turn red litmus paper blue. Super simple, isn't it?
But wait a minute. How do we know if something is an acid or a base? And please, my dear children, we should never ever taste chemicals in the lab. That is a very big no-no. So, how do we find out? That is where our chemical spies come in. We call them indicators. They are these magical substances that change their color to give us clues, just like a detective.
Okay, now, everyone, pay close attention. This table you see here, it is so important for your exams. You have to learn it by heart. So, we already know litmus, right? Red in acid, blue in base. Easy. Then we have another spy, methyl orange. It also turns red in acid, but in a base, it turns yellow. And finally, my favorite one, phenolphthalein. This one is a little bit of a drama queen, In acid, it's completely colorless, nothing to see. But the moment it meets a base, poof, it turns into this beautiful, bright pink color. So please remember this table.
All right, we've met all our characters. Now it's time for some action. Let's see what happens when our heroes face some big challenges, which in the world of chemistry, we call reactions.
So, the first challenge is the battle with the metal monster. What happens when our hero, Acid, takes on a metal like zinc? Look at the setup here. It's just like in your textbook. When we drop some zinc pieces into the acid, what do you see? Bubbles. Lots and lots of bubbles. And whenever you see bubbles like that, you know that a gas is being made. And here is the golden rule. You must write this down. Whenever an acid reacts with a metal, you will always get two things, a salt and hydrogen gas. That's it. Acid plus metal gives salt plus hydrogen gas. Simple.
Okay, I can hear you asking. We see bubbles, sure, but how can we be 100% sure that it's hydrogen? It could be some other gas, right? In science, we always need proof. We can't just guess.
Well, for this, we have a super famous and fun test. It's called the pop test. What you do is you bring a burning candle or a matchstick near the mouth of the test tube, and if it's hydrogen, pop! You'll hear a cute little pop sound. And let me tell you a little secret. This is a guaranteed 1-mark question for your exam, so you have to remember the pop test.
And now, it's time for the final showdown. What do you think happens when Team Acid finally meets Team Base? It's like a big fight where both sides are equally strong. They completely cancel each other out. They neutralize each other. And that's exactly why this is called a neutralization reaction.
And when this epic battle is over, what are we left with? We get a completely neutral substance, which is salt, and just plain old water. So the acid is gone, the base is gone, and all we have is peace. So remember, acid plus base gives you salt plus water. You must remember this one too.
Wow, you are all doing so well. Now that you've mastered these reactions, it's time to unlock a brand new superpower, the power of the pH scale. Let's check it out. So, what is this pH scale? Just think of it like a power meter from 0 to 14. Right in the middle, at number 7, things are neutral. That's your pure water. Now, anything below 7 is acidic. And the lower the number, like 1 or 0, the stronger and more powerful the acid. And anything above 7 is basic. The higher the number, like 13 or 14, the stronger the base. Got it?
And this pH scale isn't just some boring thing in your textbook. It's literally everywhere. After you eat a big plate of biryani, the acid in your stomach has a super low pH, like 1.5, to digest it all. And the toothpaste you use in the morning, that's basic,
Why? To fight the acids that bacteria make in your mouth, which prevents cavities. See? The pH scale is all around us.
Okay, so we keep talking about salt, salt, salt. We know it comes from neutralization, but did you know that the normal salt you have in your kitchen, your common table salt, is actually a treasure chest? That's right, it's hiding some amazing and useful chemicals inside.
Let's open this treasure chest with a special process. It's called the chlor-alkali process. I know, the name sounds a little complicated, but the process is really simple. It's like magic. Step 1, you take salt and dissolve it in water. We give this salty water a special name, brine. Step 2, you pass electricity through the brine. And for step 3, poof, you get 3 new treasures: sodium hydroxide, chlorine gas, and hydrogen gas.
And what can we do with these amazing treasures? Oh, so many useful things for our homes. We can make baking soda, which your mummy uses to make crispy, fluffy pakoras and cakes. We can make washing soda to get your dirty school uniform super clean. And we can make bleaching powder to make things sparkling white. Just imagine, all of this comes from our simple common salt.
Okay, one last little secret before we move on. You've seen those beautiful bright blue crystals of copper sulfate, right? They look completely dry, but actually they are hiding tiny water molecules deep inside them. It's like they have a secret water bottle hidden inside. This secret hidden water is called the water of crystallization.
You have done it. You've learned about the characters, the reactions, the superpowers, everything. So now it's time for a victory lap. Let's practice a real exam question and show everyone how smart you've become.
Okay, here we go. This is a very, very common question that comes in the board exams, so listen carefully. What is plaster of Paris, and why should it be stored in a moisture-proof container? Meaning a container that keeps water out. Think about it for a moment.
Ready for the answer? For the first part, you must remember the chemical name calcium sulfate hemihydrate. That hemi just means half. And for the second part, why keep it away from water? Well, because if plaster of Paris comes in contact with moisture, it reacts and turns into a very hard, solid rock called gypsum. And then it becomes useless. And that's your perfect 2-mark answer.
And that is it. You are now a champion of this chapter. So let's do a super quick revision. Acids are sour, bases are bitter, indicators are our little spies. Acid plus metal gives pop, hydrogen gas. Acid plus base gives salt and water. The pH scale is our power meter from 0 to 14. And common salt is a treasure chest. You've totally got this.
I am so proud of you today. You have completely mastered this chapter. Now, I have a little homework for you. Go in your kitchen right now and find me one example of an acid and one example of a base. Tell me what you found in the comments below. And of course, if you love this adventure, please like the video, share it with all your friends, and subscribe for more. Keep learning, my dear students, and I will see you in the next one. Bye-bye.